All right, we're going to do a little practicing with some different type of ratios in this video. And on this first page, you see a table. We're going to do the first one together, first line together, and then I'm going to ask you to try the rest on your own. So if you look at it, we are given a ratio using the word 2, and we're going to change it first to be a fraction, then we're going to write it as a decimal, and then we're going to go ahead and interpret that. So in the first one, we have 100 senators to 50 states. Well, when you're writing that as a fraction, the one that goes on top, it's whatever comes first. So I'm going to start with 100 over 50 for our first piece. Now, it does say reduced. So 100 over 50 reduces to 2. So that reduced is just 2. And as a fraction, it's 2 over 1. So if I think about writing that as a decimal, it's still just going to be 2 because it comes out nicely in this particular problem. Now, when you're doing an interpretation, you still need to think of it as the fraction because on top we have the senators and on the bottom we have the states. So our interpretation, we have 2 senators for each state. Right? Because each means 1. So there are 2 senators for 1 state. And that makes sense if you know your government, I guess. Okay, so I want you to try this. And it says pay attention to the labels or the units because when you're doing your interpretation, you need to use those units to talk about your interpretation. So hit pause, try the last 3, and then come back and hear the explanation. So you see in each one of these, we have whole numbers. Now you can think of this as 2 to 1, 9 to 1, 85 to 1, 15 to 1 when you're talking about per 1. But what it comes down to when you look at your interpretation, we have 9 months for every 1 year, right? You might think of this maybe as jail sentences. You serve 9 months, it counts as a year. So there's 9 months for every 1 year, maybe something like that. And the second one, 85 minutes for every hour. For every 85 minutes of work you do, you get an hour of playtime, right? You can do these kind of ratios. On the last one, it ends up with being 15 students for each faculty member. A lot of schools will talk about their student-faculty ratio, and that right there is what it means. All right, so let's go to number 2, or the next problem here, number 1. There are approximately 1,518,550 inmates in federal and state facilities in the 50 U.S. states. Part A, find the ratio of inmates to states. Okay, so inmates comes first, so we know that's going to go on top. States is going to go on the bottom. So there are 1,518,550 inmates, 50 states. So that's a really large fraction. It's hard to really understand what that means. But if we reduce that, we end up with 30,371 to 1, right? Again, knowing inmates is on top, states is on the bottom. So if we think about interpreting your answer, there are 30,371 inmates in each state, or for each state, depending on how you put it, because we have 1 in the bottom, so for each works. Now in part B, if $8.35 billion are spent in health care for the inmates each year, write the ratio of health care costs to inmates. So now we're going to put the cost on top, and the inmates are going to go on the bottom. Okay, now billion means 9. So I'm going to take this decimal point and I'm going to move it 9 places, filling in zeros. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And that is 8.35 billion over my inmates of 1,518,550. Again, we're going to go ahead and change, reduce that, use our calculator, divide the top number divided by the bottom. And we end up, I'm going to round to the nearest dollar for easiness, about $5,499 per inmate. So there's your meaningful sentence. Each inmate, right, because inmate's on the bottom, for each inmate, the cost is approximately $5,499. Okay, and that's kind of a way to handle that one. And the last problem that we're going to deal with here, the table at the right has the number of people for each age bracket for a certain county in Indiana. Let's find the child, old age, and age dependency ratio for this information. Okay, now, on this particular page, I just want to recap child dependency. That's the children over the working class. The old age is the oldies compared to the working class. And then the age dependency is the young people plus the old people compared to the working class. Okay, so those are the fractions. So let's go ahead and do that. If we are dealing with the children, we know from that table there are 6,734 children and there are 21,241 working class. Again, that fraction doesn't really tell us anything. But if I divide that, top number divided by the bottom number, I end up with a 0.317. So that means there are 0.317 children dependent on each worker. If you don't like that, 3 places is 1,000, so you can say, if I have 0.317 and I move this, that's over 1, if I move it 3 places, I can move this 3 places, and I have 317 over 1,000. So that means we would have 317 children dependent on every 1,000 workers, right? So you have 2 ways that you can interpret that, depending on whether or not you like decimals or if you want to use more of whole numbers. All right, let's go to the oldies. So if I look at my oldies, I've got 5,528 oldies compared to my 21,241 workers. Again, I'm going to divide that, top divided by bottom, and I get 0.260. So that means there are 0.260 oldies dependent on each worker, because this is like having it over 1. And again, we can move it 3 places on the top, 3 places on the bottom, and we can always say 260 oldies dependent on 1,000 workers. And the last one, just straight up age dependency, is where we get into, we have the young ones, let's add that to the old ones, and we divide it by our workers. So I end up with 12,262 divided by 21,241 for a decimal approximation of 0.557. You can think about it over 1 if you'd like. So there are 0.577 dependents on each worker. So each worker is supporting themselves and then more than half of another person based off of this data.